Alright, moving on to the atomic emission spectroscopy. Three very weird words. There are definitely key concepts towards this topic. We have quantization, which describes the atoms and molecules that can exist only in discrete energy levels. This basically describes how the two partners, atoms and molecules, can only exist in different energy levels, lower energy levels and higher energy levels. Now, the actual term spectroscopy is basically a technique used for the interaction of energy with a sample to perform an analysis. Now, what this basically means is that we have different ways of finding energy, and with that energy we can perform an analysis. This kind of relates to the E equals hv sort of formula, which we will go on to later on in this video. For now, we're going to move on to the excitation and emission spectroscopy. There are two different types. Excitation basically describes the valence electron promoted to a higher energy orbital. And the emission spectroscopy describes valence electrons dropping into a lower energy orbital. Now we know this because their electrons usually go higher and lower depending on how excited they are in terms of heat. Electrons can be heated up and they can suddenly get excited, meaning they can go up to a higher energy level. We can see that in this diagram. As you can see, we have a diagram showing the energy level going up because of an excited state, and we have an energy level going down because they are no longer excited. Now we can classify these two as the two different types of spectroscopies that we discussed earlier on. We can consider that the first one can be described as excitation. Excitation spectroscopy, because the excitation spectroscopy, describes how the electrons usually get excited, and they go higher and higher as they get more excited. So we can consider that as excitation spectroscopy. Let me just make it more wider. And the next one we can consider obviously as the emission spectroscopy, because the energy level starts to go down and the electrons start to go down to a lower energy level because they're not as excited as they were before. So to make it easier, let me just copy this part and just separate it, bring it to the other side, and we can call this the emission spectroscopy. This is what these two usually look like, and this diagram perfectly describes the energy levels. Finally, we can use this to provide evidence for energy level in the atoms, because by exposing these atoms they jump to a higher energy level because of the temperatures that they are in, and they also emit light in the end. As we can see through this diagram, the red rectangles represent energy levels.